Hi everyone, welcome to Math Moment with Mr. Dustin. I'm Mr. Dustin. So today we'll be discussing solving linear equations. And so this is a concept that is generally taught in 8th grade, but it is very valuable beyond that. It is especially valuable on the SAT. So it will definitely be a great review for anybody who wishes to learn about this again. And it is also a great preview, as this is it's a fundamental concept in algebra. So there is also a formative assessment at the end of this. I would appreciate it if you'd take that. The link is in the description. Enjoy the video. All right, so today we're going to be discussing solving linear equations, and this is actually one of my favorite aspects of math. It works out really well. This is an algebra concept, and algebra is my favorite subcategory of math. Anyways, the goal of this is to solve the equation for the missing piece, x. So we'll be given everything else, and we just need to solve for x. All of the equations we will see will take some kind of variation of the y equals mx plus b form. And so that will be very helpful because this is just a method to solve those specific types of equations. So let's talk about how to do that first before we do any examples. So first, we have to remember that addition and subtraction go together, and multiplication and division go together. Now, what does that mean? Well, if we take 1, for example, and we add 1 to it. So 1 plus 1 equals 2, right? Okay, that makes sense. 1 minus 1 equals 0. That also makes sense, right? Well, what we're trying to do is we're going to use this concept of subtracting things like this. So we have a positive 1 and a negative 1, and those will cancel out to be 0, right? And so we can apply the same thing with negative numbers. We could say like negative 2 plus 2 equals 0, just like that. So that's kind of the principle we'll be using. These things cancel each other out, which will be important for solving these equations. The other thing is multiplication and division, right? So we could say 3 divided by 3 equals 1. Or we could say that 4 divided by 4 equals 1. Or you could say 1/5 times 5, which is technically 5 over 1, equals 1. So the idea is that we're going to make these things, the multiplication and division, simplify to 1, and we're going to make the addition and subtraction cancel out to 0. So we will definitely see these, in play with our examples here. Second, let's remember the order of operations. So you do parentheses, exponents, multiplication, division, addition, subtraction. So normally you would do this, in this order that they're listed here. But with these, it works best to do them in reverse order. And we'll see why later on when we do more examples. But for now, this is kind of what we'll have to do. So to explain the rest of how to do that, let's look at some examples. So our first example here is 3 equals x plus 2. Now what I'm going to do is I'm going to draw a line right down the middle here of this equal sign. And what that'll mean is that we're going to keep everything that's on the left side of this equation on the left side, and everything that's on the right side of this equation on the right side. So let's find out a way to get x by itself, because that's what we want to do. We want to say x equals something at the end. So how would we cancel out this 2? We want to make this a 0. Well, we'll use the principle that we just talked about with addition and subtraction. So I'm going to put minus 2 right here. That's a really big minus 2. We'll just kind of do that. We subtract 2 on that side. Well, what you do to one side, you have to do to the other side of the equation. Otherwise, it will not be equal still. So I'll put a minus 2 for the left side, just like that. Now, what is 3 minus 2? Well, that is 1. So we'll go back to the blue here. 1 equals, well, now what's remaining on the left side there? Or sorry, the right side. X is remaining. Technically it's a plus 0, but that doesn't mean anything because when you add 0 to something, that doesn't change it. There we go. 1 is equal to X, and that is our answer. Now, to verify it, let's plug in 1 to that equation again. So 3 equals 1 plus 2. Is that an accurate statement? The answer should be yes, it is accurate. So that means we have the correct answer. So that's a good thing. Now let's look at the next example here. We'll draw a line again, and we'll start going through these a little faster now since we got the basic idea. So what we want to do is cancel the 5. So I'm going to have a plus 5 and a plus 5 because we have to do it to both sides of the equation. So, oops, we'll go with, come on, 5 right here. So that'll make the 5s cancel. And then we have a 5 over here. 10 plus 5 is 15. So we'll say 15 equals X, and that is the correct answer. And remember, you can still verify it. I'm not going to, but you are more than welcome to verify it by plugging 15 back into the equation. And it's pretty easy. 15 minus 5 is definitely 10. So now let's look at a multiplication problem here. This time, what we want to do is make it so there's a 1 being multiplied by the X, right? Because 1 times anything is itself. So what I'm going to do is I'm going to divide by 2 and divide by 2. Because remember, what you do to one side, you have to do to the other. So we're going to divide by 2 on both sides. 2 divided by 2 is 1. So it'll be 1x remaining on the right side of the equation. And then on the left side, 6 divided by 2 is 3. So we can say 3 equals x. Oops, I canceled that instead of placed it. 3 equals x. And we can verify that by plugging 3 back into the equation. 2 times 3 is most definitely 6. And so we know we have the right answer. Finally, draw another line here. And what's the first step we want to do? Well, we want to divide by 4 on each side. Like so. 4 divided by 4 is 1, so we are left with 1x on the right side of the equation. And then 8 divided by 4 is 2, which I'll get there in just a moment. So that means 2 equals x. And we can see that because 4 times 2 is indeed 8. So there we go. That is the beauty of solving equations. You can always verify to see if you have the correct answer. So this is just the basic example. Now there are more examples that we will go over, but this is kind of the basic concept of it so far. And with that, we're going to go into a break. So enjoy that. All right, so for the break today, I figured I would tell some math jokes, just because you can joke around about math. I think it's pretty fun to do that. So here's the first one. Why is the obtuse triangle always frustrated? Because it was never right. Okay, this one's pretty relevant to what we did today. Dear algebra, stop trying to find your x. They're never coming back. Don't ask why.
Brain.
Laugh it up, fuzzball.
How do you stay warm in any room? Just huddle in a corner where it's always 90 degrees.
It's not funny, Ed.
And finally, the roundest knight at King Arthur's table was Circumference.
That's a fake laugh.
It's real!
Hi, everyone. Welcome back. I hope you enjoyed the break. So let's take a look at some more examples of solving linear equations. We'll finally get to see reverse order of operations in play now. So let's look at this first example on the left here. I'm going to draw my line.
That is not a straight line, but that's okay. The point is that there's kind of a line dividing the left side and the right side. So our first step that we will want to do is to get rid of this 3. We want to cancel it out so that it's just x over 2 equals something on the left side. So what we can do is we can subtract 3 from each side. We'll use the orange. Subtract 3, subtract 3. So we're going to do that. Now what I'm going to do at this point is I'll write down where we're at. So 9 minus 3 is what? 6 equals, and what's remaining? X over, or negative x over 2 plus 0. So we'll just say negative x over 2. So this is now our new equation. And these are still equal, so that's a good thing. Now what we can do is we can multiply by negative 2. Because we're dividing technically by negative 2 right now. So we're going to multiply, I'll put times negative 2 and times negative 2 on each side. And what that will do is it will cancel out this division right here with the x's. So we want to have a positive x by itself. That's the key. You want positive x. So what is negative 2 times 6? Negative 12 equals x. And so that is our new equation. And it's what x equals. So there we go. And we can plug this back into the equation, right? So we could say negative 12 divided by negative 2 plus 3 gets us 9. So feel free to verify that with a calculator if you don't trust me. Let's take a look at the right equation now. Divide it right there through the middle. What's the first thing we're going to want to do? We want to get rid of this 4, or this negative 4 rather. So if you're subtracting, we have to add, because that's the opposite of subtraction, and it'll cancel out to be a 0. So plus 4, plus 4. There we go. What is remaining? 5 plus 4 is 9, which is equal to 3x plus 0 technically, but we don't care about the 0 because it's not really adding anything. So we can leave it out. So this is where we stand now. 9 equals 3x. Now what do we need to do to get x by itself? Well, we just divide each side by 3. And why is this? Well, we'll end up with 1x equals 3. Spoiler alert, this will end up being 3. Because 9 divided by 3 is 3. Remember, we want 1x to equal something. So 3 equals x. And if we want to verify it, we definitely can. So 3 times 3 is 9. And then subtract 4, we get 5. And that matches. So we know we have the right answer. Now we're going to look at one more thing today, and it is the distributive property. And so what this means is that when there's something next to the parentheses like this, you want to essentially do what they call distributing, which is you multiply what's outside by both of the things inside. So 2 multiplied with x becomes 2x, and 2 multiplied with 3 becomes 6. So you can see how this becomes 2x plus 6. Let's take a look at this example. We want to multiply 3 and 4, and then 3 and negative x. So that is going to be equal to, let's see, well, what's 3 times 4? That is 12. And then 3 times negative x is negative 3x. So that is our answer to this one right here. it's basically, if it helps you, just draw the lines, you know, like I did here. 3 times 4, 3 times negative x, 2 times x, 2 times 3. So let's see one more example of that in action, and we will actually solve for x. So here's our first step. Instead of trying to get rid of something, what we can do is distribute this 4 right here. Now, some of you might say, well, we can divide by 4, and you're right. There are multiple ways to do this, and perhaps I'll show the second way you can do this on the other side over here. But first, let's look at this as we distribute it. So after we distribute, we have 8 equals 4x plus 4. And you can clearly see all we did was we multiplied by 4 for both the x and the 1. That's all we did. So now we can follow our other steps, right? Subtract 4 from each side, like that. And so that will bring us to 4 equals 4x. Just like that. Oops, not quite on the line there. And I'm going to extend the line a little bit. Now I'm going to divide by 4. Just like that. And then 4 divided by 4 is 1. And then 4x divided by 4 is x. So 1 equals x. And you can definitely plug 1 back into the equation to see that in action. So you'd say 1 plus 1 is 2 inside the parentheses here. 4 times 2 is 8. Now, real quickly, the other way we can do this, let's see, 8 equals 4 parentheses x plus 1. Just kind of make a side note over here. What we can do is we can draw a line like so. We can divide by 4 first this time. So my point I'm trying to make here is there's not one way to solve these every time. You can do this multiple ways. And so that's what we're seeing here. 2 equals x plus 1. That's what's remaining after we divide by 4. So now we can subtract 1 from each side. And we can see that the answer is going to be 1 again. Because 2 minus 1 is 1. So 1 equals x. And it's the exact same thing. So you can do whichever method works best for you, but the point is there's not always one way to do this. So yeah, this is solving linear equations. I hope you found this helpful. There is a formative assessment and the link is in the description if you'd like to take that. Thank you for watching this video.